this class we will solve a few problems which is related with the magnetic field due to current carrying a circular coil. Okay, and here just we are going to use in these problems in even those special cases problems also. Okay, so now just to look at this problem, so how you are going to solve this one. Okay, so here a current of 1 ampere is passed through a coil of radius 31.4 centimeter and number of turns 50. See, just to mention here, just to try to understand the problem here, the number of turns, how much they had given, 50, and what is the radius of the coil, 31.4 centimeter. Okay, and what is the current they had given, 1 ampere. Just to note down, just to try to note down which is the given important parameters, and what they had asked here, the magnetic field at the center of the coil. Okay, 1 point, and another one is and 5 centimeter away from the center. And even though they had given the another value also, we need to find the if the away from the center, what will be the magnetic field. Okay, so right now here, before going to this, just to write down the given parameters, whatever they had given. They had given the current I, that is 1 ampere. Okay, and here what they had given the radius, that is 31.4 centimeter. Is that right? And here how many turns they had given, n is equals to, I can write this one as in write A or else R. Okay, which is dependent on the formula, whether if you have replaced the radius by R or else A, that is left for you. Okay, don't get confused. And how many number of turns here, 50. Okay, that is n. And another one is what they had given. Okay, and even though already we know that the naught value also, that is 4 pi into 10 to the power minus 7. Is that right? Then it is Weber per ampere meter. Okay, and now here these are the given things, and from that I am going to find the magnetic field at the center of the coil. And already we know that what is the formula if the magnetic field is present in the center of coil. So that is B is equals to mu naught I by 2R. That's it. Okay, so now here I had considered the radius as A, or else you may write like this. Here this is R also, because here I had taken this one as a R. Okay, and now here substitute the values. So here substitute the values. 4 pi into 10 to the power minus 7 into current is 1 ampere whole divided by 2 into what is the radius you are having, 31.4 centimeter. I can write this one as a 0.314 meter. So simply substitute 314. And now here there is another one parameter missing. How much they had given, given the number of turns here, there are 50. So now n mu naught by I by 2R. So I can write the number of turns, that is into 50. Okay, and now here, so this is what the all the parameters what we have substituted, and finally after the calculation and simplification, finally I think so approximately we will get 10 to the power minus 4 Tesla. Okay, just to simplify this one, we will get the answer, and once it verify this one. Okay, and now here, so this is what the first case. Okay, and in the second case, what they had given the how much the away from the center. Okay, 5 centimeter. So that is they had given that x is equals to 5 centimeter. You may write like this 0.05 meter. Okay, and now I can write. See here, if the magnetic field away from the center, for that case would be having the formula, that is B is equals to mu naught Ni whole divided by 2 into a square plus x square to the power 3 by 2 here. This is what a square. Okay, and now here substitute all the values. What you are having the mu naught 4 pi into 10 to the power minus 7 into 50 and into what is the current you are having 1 and what is the radius you are having r, that is what a 0.314 whole square and whole divided by 2 into what you are having the a value 0.314 square plus x, what they have given 0.05 whole square and now to the power 3 by 2. Okay, and now finally what we got it here, just we have substituted all the known parameters. Okay, and finally simply just we need to simplify this one and finally you will get the answer, I think so approximately, that is 9.63 into 10 to the power minus 5 Tesla. This is what the answer for the second case, the magnetic field. So finally what we got it is just to simplify and once verify the answer. Okay, and now here see simply we solve the both the cases. Magnetic field at the center of the coil is how much the magnetic field you are having, it is 10 to the power minus 2 Tesla. Okay, and even if the magnetic field 5 centimeter away from the center, okay, the distance how much they had given, that is x is 5 centimeter, at that point what will be the magnetic field 9.63 into 10 to the power minus 5 Tesla. Okay, so this is what how we are going to solve the examples which is related to the this concept. Okay, thank you. Okay, so we'll go with the next example. Just to look at here, find the magnetic field due to circular coil of radius 0.1 meter. What they had given them, the radius of this circular coil is 0.1 meter and here which is having the number of turns, those are 200. Okay, and at the center of the coil when circulating current is 500 milliampere. They had given the 3 parameters. Okay, and from by using those given parameters, just you are going to find the what will be the magnetic field. Okay, just to look at the solution here. Okay, and now here just to take down the given things. What they had given, they had given the radius 0.1 meter. Okay, and the number of turns that they had given the 200. Okay, and how much the current is, current is 0.5 ampere. Just I have converted that to milli to the ampere. Okay, and now they ask the what will be the magnetic field. Okay, so now at the central point of the coil, so what will be the formula for the magnetic field? So we know that already, that is B is equals to mu naught and I by 2R. Okay, so and even though just what is the another required thing, mu naught also, mu naught how much we know that how much we are having, 10 to the power minus 7 Weber per ampere meter. Okay, simply substitute all the values. 4 pi into 10 to the power minus 7 into number of turns how much you are having, 200, and what is the current you are having, 0.5 whole divided by 2 into radius of the circular coil, that is 0.1 meter. Okay, and now here just to simplify, already we have substituted all the required parameters. Okay, simply just to calculate this one, you will get the final answer of this problem is 0.638 into 10 to the power minus 3 Tesla. Okay, so this is what the magnetic field due to circular coil, that is by using all these parameters. This much of magnetic field is present. Okay, so this is what all about this example. Okay, and in the similar way, just to go to the next example, what we are having. In this example, what he had asked me is calculate the current in a circular coil of a radius 5 centimeters. Is that right? Okay, he had given the radius also, and even though he had given the number of turns, it is having the 100 turns. Okay, to produce a magnetic field of 2 into 10 to the power minus 5 Tesla. Just to look at here in this problem, what he had given and what he had asked. Okay, and at its center, at the center point, the magnetic field they had given 2 into 10 to the power minus 5 Tesla, and he asked me here, you are going to find the current. Okay, so now before going to find that, just you need to write the given things. What he had given, he had given the radius, that is 5 centimeter, that is what I can rewrite this one as the 0.05 meter. Okay, and the number of turns, how much he had given, 100. Okay, and even though he had given the magnetic field also, that is 2 into 10 to the power minus 5 Tesla. Is that right? And now what he asked here, he asked me here current. What is the current in circular coil here? Simply already we know that the formula, that is B is equals to mu naught and I by 2R. Is that right? And now just I am going to modify it here because I am going to find the what is the current. Okay, so I can rewrite this one as I is equals to 2 dr upon n mu naught. So that's I substitute all the values. Already we know that. So that is I is equals to 2 into magnetic field, how much you are having, 2 into 10 to the power minus 5 into what is the radius of circular coil here you are having, 0.05 whole divided by number of turns, how many you are having, 100, right? 100, and mu naught value already we know that 45 into 10 to the power minus 7. Okay, so right now if you simplifying this numerical part, finally we will get the current, that is 15.9 milliampere. Okay, so now just to simplify this one and verify this one, you will get the answer, that is 15.9 milliampere. Okay, so this is what the final answer with respect to this problem. Okay, and also these are the kinds of problems which is related with the magnetic field due to circular coil, current carrying the circular coil. Okay, so thank you.